Today we are going to talk about forces. A force is a vector quantity. It's a quantity that has both magnitude or size and direction. The length of the vector is the magnitude and the arrowhead shows the directions. So there's three different scenarios that we are going to focus on today. The first scenario is if, say for example, I take this box and I'm going to just shade it in here. So just watch for a minute. I'm going to take this box, and the 10 is my force. And we'll say the 6 here is your force. So if together we pull on, so this is my force, this is your force. So I'm going to pull this box this way, and then you're going to pull this box to the right. What do you think is going to happen? If we're both pulling in the same direction and I pull it with a force of 10, say 10 pounds, I'm pulling it at 10 pounds, you're pulling yours at 6. Collectively, this box is going to move at a net force of 16. That's scenario number 1. Okay, scenario number 2. Say again, this blue one is my force, and this 6 is your force. And again, we have the box in the middle. So I'm pulling the box to the right. You're pulling the box to the left. So if I'm pulling the box to the right with a force of 10, so say 10 pounds, and you're pulling it to the left with, say, a force of 6 pounds, it's kind of like we're playing tug of war. Who's going to win? I'm going to win. My force is going to win, and I'm going to win by a force of 4. So this box over here is going to move in a direction to the right 4 pounds. So we'll say we're using 4 pounds of pressure to push it. Okay, these two scenarios are easy. The first scenario, we're either going to add the two forces together. The second scenario, we're going to subtract the two and take the bigger one, the direction of the bigger one. But that's easy. We're not going to do that. Algebra 2 trig type questions focuses on scenario number 3. So scenario number 3 says, if two forces pull on an object in directions that form an angle other than a straight angle with each other, effect is that of a single force in the direction shown below. And this force is called the resultant. So what did we just read? Again, here's the box. And we'll say this one going up, I'm pulling the box up, is my force. And we're going to say yours is down here pulling it straight horizontally. So this is yours. So now which way is this box going to move right here? Am I going to go up? Am I going to go right? Am I going to go down, left? Where is it going to go? And at what force? Meaning 10 pounds, 30 pounds. What is it going to be? Well, right here is where the force is going to go. It actually goes not in the middle, but it goes kind of in the direction of between these two. Again, not in the middle, because if it were to go in the middle, we'd both have to be pulling at the same force. So this is an example, what we're going to have. So in the accompanying diagram, we've got PQ is one force, PS is another force. So if applied force 1 was, say, I don't know, 10 pounds, and we'll say applied force 2 is 6 pounds, this resultant force is the direction that that box is going to go in, and the box is always here. That's where that box is. So again, this one at 10 is going up. I'm pulling the box up. This one over here at 6, I'm pulling the box to the right. Okay, so what's going to happen? Well, that box is going to move in a direction here. Now this angle in here is not going to be the same because they're not the same forces. So let's try some examples. Let's go to the next page. Okay, example number 1 says, forces of 40 pounds and 70 pounds act on a body at an angle that measures 60 degrees. So let's draw every single picture the same way. We'll put the body that we are going to be moving here. This is my body. If it helps to label it, we can label it. This is the body. And it says forces of 40 pounds and 70 pounds. So we're going to draw them the same way in the diagram on the front page. So I'm going to be pulling it up with a force of 40 pounds. You are going to be pulling it with a force of 70 pounds. So notice how I did that. And they're on an angle of 60 degrees. So we're both at an angle of 60. So again, that's the picture. The body is always going to go here, and the two forces are always going to look like this. And then what we can do is we can make a parallelogram out of this. Why do I need the parallelogram? I need the parallelogram because I want the magnitude of that resultant force. And remember, that resultant force is that force right here, which we'll call R for the resultant. This should look familiar to you. This is a parallelogram. We're going to use law of cosines for this. So let's go ahead and label what we know. Don't we know that if this side is 40, that this side will be 40? And that if this side is 70, this side up here will be 70? Okay. And I want to isolate my attention on this triangle on the bottom, because again, I always like the bottom triangles. So law of cosines tells me I have 3 sides and an angle. And this angle I can't cut in half, so I got to pick this angle in here. Remember, this angle in here is 180 minus this angle. So this one would be 180 minus 60, which would give me 120. So now I have law of cosines, 3 sides and an included angle. So go ahead, set up law of cosines, pause the video, get an answer, and then I'll hit play and you can see my work. Okay, the way I set it up was r squared comes first, because remember, with law of cosines, if this is the angle you have, this side comes first because it's the side opposite. And then when you put this whole piece here into the calculator, you get 9,300. And to get r by itself, you just have to take the square root. So r is 96.436,507. And it says round to the nearest hundredth, so that's 2 decimal places. So my resultant is 96.44 pounds. Okay, let's try example number 2. So in example number 2, it says one force of 20 pounds and one force of 15 pounds act on a body at the same point so that the resultant force is 19 pounds. So before I read any more, let's draw a picture. So again, we're going to draw the picture the same way. We have a body, an object that we are pulling. And we're going to label it that it's our body, if that helps. One force is 20 pounds. The other force is 15 pounds. Now I'm going to go ahead, draw the parallelogram before I draw in the resultant, because it's just easier to connect it. And they do tell us that the resultant force is 19 pounds. And since it's a parallelogram, I can go ahead and label the opposite sides so that they're the same. So this is 20, and this is 15. So what do they want us to find? Find to the nearest degree the angle between the two original forces. So they want this angle in here, this whole angle. Now again, since we know we're going to use law of cosines, we can just focus our attention on this bottom triangle. So in this bottom triangle, I have 3 sides, and this little angle in here I don't have the whole angle. So if you're thinking, find this angle and double it to get the whole thing, you technically be wrong, because remember, unless these two forces are the same, you can't cut it in half. So I think our easiest bet is going to be to find this angle first. We'll call it x. If we find this angle, what's the relationship between this angle and this angle? You should be saying they're supplementary angles. So this angle plus this angle adds up to 180 degrees. So if I find this one, all I have to do is subtract from 180 to find that one. So let's set up law of cosines. Pause the video, set up law of cosines, and solve for x. Okay, take note in how I set this up. Since I want to find angle x, we have to put on the equal sign the side across from it. So that's why I put this 19 here, and the x goes on the other side. So 19 squared gives us 361. 20 squared is 400. 15 squared is 225. And if you multiply 2 times 20 times 15, you get 600. Now we can add these two together, and you get 625 equals 361 minus 600 cos x, and we can subtract 625. You'll get negative 264 over equals negative 600 cos x divided by negative 600. You should get that cosine of x is equal to 0.44. And remember, to find x, you do the inverse of cos. So second cos, second answer, and you get 64 degrees. And to find the angle up here, we would just do 180 minus 64. So this angle, I guess I'll put a little arrow, is 180 minus 64, and you get 116. That's your final answer. Okay, last example. Two forces act on a body to produce a resultant force of 70 pounds. One of the forces is 50 pounds, and it forms an angle of 67 degrees 40 minutes with the resultant force. Okay, before we read further, let's draw a picture. So again, we're going to have a body. Two forces acting on it. So you can go ahead and draw in parallelogram. So it tells you that the resultant force is 70 pounds. So I can go ahead and put 70 for the resultants, and one of the forces is 50 pounds. Okay, and they say one force is 50 pounds, and it forms an angle with the resultant force. Here's the 50 pounds, and here's the resultant force. So this angle in here will be 67 degrees 40 minutes. Okay, now since we have the angle in the upper triangle, maybe we'll focus our attention here just for argument's sake. Alright, and they want to know the magnitude of the other force. Well, the other force is this one right here. And isn't that going to be the same thing as this one up here? So let's isolate and look to see what we have here. We have three sides, 1, 2, 3, and an angle. So we actually can use law of cosines for that. So let's go ahead and do that. Pause the video and come back and meet me at an answer. Okay, your answer for the other force should be about 69 pounds. Take a minute and look how I plugged everything in. If you have any questions, ask me about that in class tomorrow. So let's look about part B. So it says, find to the nearest degree the angle formed between the two given forces. So they really want this whole angle. So we have half of the angle, not necessarily half, but we have a portion of the angle. We have the 67 degrees, 40 minutes. We need this other piece in here. Well, we could do what we did last time. We could ignore this little piece, and we could just say, okay, well, if I know this angle, then I can just do 180 minus that to find this whole angle. So I think that's what I'm going to do. So let's set up law of cosines again. So pause the video and meet me at a solution. I'm going to call this angle up here y. Okay, so the way I set this up is 70 is my starting side because this is the angle I want to find. So I did 70 squared equals 50 squared plus x squared, but x was 69. 2 times 50 times 69 cosine of y. Figured out what these were, subtracted it. Then I divided, and I got cosine of y is equal to approximately 75.762. But remember, that's y, which is this piece up here. I want this angle. So this whole angle here is 180 minus that 75 point blah, 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 blah. So in the calculator, you should already have the 75.7627 blah, 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 blah. Do 180 minus that and do second answer. You get about 104.237, and what we want to do here is put this in degree minutes seconds because we want that whole angle. So second apps 4, you get 104 degrees 14 minutes. Perfect. Final answer.